Okay, sige, let us continue. Actually, this one is a continuation of our last lesson, diba? We have discussed reactions in aqueous solutions before the intramurals. So, we discussed the different types of chemical reactions, diba? We have the single replacement, the double replacement, and then we have also the combustion reactions. And then under the redox reaction, we can have the decomposition and the synthesis reaction. So I hope you can still remember those things. We still need those things for our succeeding lessons. So to continue with reactions in aqueous solutions this morning, we'll have the following learning outcomes. First, to determine the general properties of aqueous solutions, and then discuss the different common type of chemical reactions, and then identify examples of each chemical reactions. And then actually we will be discussing, let me add kasi I was not able to add this one sa learning outcomes. We will be talking about concentrations and dilutions. Though medyo nauna yung laboratory natin, but let's just have a formal discussion about concentration and dilution. Okay, so for the table of contents, we will be talking about, again, first concentration, the concentration of our solutions. And then we will be talking about gravimetric analysis, acid-base titrations, and the redox titration. So I think we can only have concentration of solutions this morning, but let us try to include the gravimetric analysis. Okay, let us start. Let's talk about concentration of solution. So when you say class concentration of solution, it's the amount of our solute present in a given amount of solvent. Okay, let me write on the screen. Remember, class, when we discussed about solution last time, we only have two components. We have the first one, the solute, and then the second one, the solvent. Okay, let me get my list for the recitation. Let's have the first one. Who can still remember the definition or the description of our solute? Because again, we only have two components of our solution, the solute and the solvent. Okay, wants to answer, wants to volunteer? Yes, Adrian.
Solute is a minor, ano po siya, ma'am? Minor solution. Ay, component po. Minor component.
Okay, what do you mean by minor component? Bakit mo nasabing minor yan? Ano nga ibig sabihin pag minor siya?
Parang including siya sa ano, ma'am, para mapag-form ng solution.
Yeah, that is included in the solution. Yes, minor. So let us elaborate that. Sian, you want to add something?
Ang solute po is a substance that present a smaller amount na siya po yung dinidissolve.
Okay, very good. So that is what we know na parang minor siya, na minor component ng ating solution. Bakit? Because most of the time, the solute is present in smaller amount. Okay? Smaller amount siya. And the solute is the one that is being dissolved when you have a solution. Now, how about the solvent? Yes, Jendi.
Substance present in larger amount po.
Okay, sige. So that is the complete opposite of our solute. When you say solvent, that is the substance that is present in larger amount. Wants to add something about the solvent? May gustong i-add about the solvent? Meron bang hindi nasabi si Jendi doon? Yes, Nicel?
In addition na po, ma'am, si solvent po yung nag-dissolve po ng mixture.
Okay, si solvent yung nagde-dissolve. Okay, if the solute is being dissolved, the solvent naman is the one that is used to dissolve the solute. So I hope that is already clear. Do not forget that these two are the components of our solution. Do not forget how the solution is a mixture. And to be exact, to be specific, the solution is a homogeneous mixture, meaning it will be presented in a uniform siya na yung kanyang appearance. Now, let's talk about the concentration. That is just a little review about solution. The concentration, again, it refers to the amount of solute. Again, amount of solute present in a given amount of solvent, or that is simply yung gaano karami na solute ang na-dissolve natin sa specific amount din ng solvent in a given solution. So in the laboratory, we had our activity about molarity. So we will have our formal discussion about molarity. This is an expression of concentration. So when you say molarity, that is the molar concentration, which is referring into the number of moles of solute per liter of solutions. As you can see in the screen, that is our formula for the computation of molarity. Moles of solute over liters of solution. So this can also be expressed as capital letter M, that is for molarity, equals N. N class, by the way, is referring to the number of moles. Though we know that the symbol for moles is MOL, diba? Moles, sinusulat natin siyang MOL, over, pwede din siyang gamiting N class, over V, that is the volume. But take note that the volume should be always expressed as liters. That is how we compute for molarity. Last time, I have given you examples of expressions of concentration. Most of the time, we use the percentage. Like when we say 100% concentrated, that is actually an expression of concentration. Okay, the percentage. Now we also have, syempre, the one that you can see on the screen, the molarity. So if you are going to have your face-to-face na classroom na class pohon, I mean face-to-face class, sa sunod if we are permitted na to do so, you will see in the laboratory a lot of chemicals na ang nakalagay, may nakalagay na number, example 10, and then may kasama siyang letter which is capital letter M. Tapos yung name ng chemical, example, hydrochloric acid. So this one actually is the concentration of that certain chemical substance. The M there is referring to molarity. Most of the time, we use molarity in expressing the concentration of our chemical substances. Though you can see percentage, pero actually we'll seldom see percentage in the lab. We don't really use that much the percentage when it comes to expressing our concentration. But actually in our home, mostly ang ginagamit talaga percentage. Sa mga bahay natin, kung gaano ka-concentrated yung ginagawa natin na solution, again, most of the time we use the percentage. Pero sa lab, either we use the molarity or we use the normality. Okay? The normality class. And that this one is expressed in capital letter N. So sometimes you will see 10 MHCl or 10 N hydrochloric acid. So please do know that this one is ito siya, ang ating concentration. Or sometimes, very, kung seldom lang natin makita si percentage in the laboratory, mas minsan pa talaga natin makita si molality. But this one is also an expression of concentration, and unlike molarity na capital letter M, yan si molality is small letter m. So example, 10M hydrochloric acid. So that's two different thing. That is why when we had our quiz last time, I was actually strict with the unit. If you have not given the moles per liter, it should be capital letter M. Do not write a small letter m because the small letter m is a different unit or a different expression of concentration. So please be mindful of that. Questions so far? You have questions? You want to clarify something?
Ma'am.
Okay, sige. So let us continue. So keep in mind, class, again, that the solution, the volume for molarity is in liters, liters of solution, not liters of solvent. So wag kayong maglagay example. Most of the time kapag yung ating lesson is computation, my quiz or my exam will be a file upload because I really need to see your solutions for this. So take note that molarity is, remember, moles. Pero moles ito ng solute. Take note, it's the moles of solute over the volume in liters of solution. So this is as a whole as a whole. Pag sinabing solution, that's solute plus solvent. So do not write liters of solvent. It should be liters of solution. So it will be as a whole, included na in the computation solute and solvent. Now, molarity of a solution depends also sa temperature. Because remember, we have chemical substances that might be soluble in a cold solution, but not soluble in a hot solution. So again, the molarity is dependent sa temperature. So, but actually, most of the time, our chemical substances will be more soluble if the solution is hot. That is the reason why, class, kapag nagde-dissolve tayo ng something, we mostly use a hot water. Kasi nga, tumataas yung solubility nila if mataas din ang temperature. Okay? So that please keep that in mind. Even in our houses, right? Even in our home, di ba pag nagtitimpla tayo ng gatas, for example, the powdered one, pag nilalagay natin siya sa mainit na tubig, most likely, you can see na the powders will be dispersed in the liquid. But if hindi natin siya gagamitan ng hot water, example, we want to have a cold one, di ba? Yung unsa mahitabo sa ato ang gatas, dili siya ma-disperse, right? And then magbuo-buo siya. Okay? So, mo na siya ang ginamin, class, na the concentration, the molarity is dependent sa temperature. The solubility is different, dependent sa temperature natin. So let us have, class, an example of a problem na mag-compute tayo ng ating concentration. Wait lang, ha? Okay. I cannot see clearly. Okay, sige. Let us have here an example of the computation of molarity of a solution. So the first thing, diba, remember in problem solving, you have to read the problem carefully first and try to understand it. So we have here a 1.46 molar glucose solution. The C6H12O6 is the chemical formula for our glucose, written as 1.46 m. Glucose contains 1.46 moles of the solute in 1 liter of the solution. So, of course, we do not always work with solution volumes of 1 liter. Thus, a 500 ml solution containing 0.730 mole of the glucose also has a concentration of 1.46 m. So actually, ganito ito. Sabi niya, we have here a glucose solution. Let me just drink water. Wait lang. Wait, like, excuse me, sir. Okay, sorry. Sorry for the interruption. Let us go back. Again, according to, this one is actually just an illustration. According to this, we have here a glucose solution. Again, we have a glucose solution here. I have explained this one last time. When you say glucose, this is our physiological sugar. And then other name for this is dextrose. So if you want to prepare a dextrose or a glucose solution, you have here, what's the given? The concentration is 1.46 m. Again, the concentration, okay, sige, is 1.46 m of the glucose solution. And when you have this one, it means, class, na, di ba? Itong capital letter M is equivalent to moles per liter. Pag ganito daw ang concentration mo, it means you have here 1.46 moles of the glucose, the C6H12O6, dissolved, class, in 1 liter of the solution. Yan yung meaning ng 1.46 m. Again, meron kang 1.46 mole of the glucose dissolved in 1 liter of solution. Okay? So that is again the meaning. But in the laboratory, we don't actually prepare, most of the time, we don't actually prepare 1 liter kasi tingi-tingi lang naman yung ginagawa natin sa lab. Most of the time, gumagawa tayo ng mga solutions na lesser than 1 liters. So you have to know also that if you have here daw, according to the example, if you have daw a 500 ml of solution, but the moles is 0.730 moles of solute, if you compute for the concentration, it will be the same as this. Okay? So let us please get your calculators there because we will have a lot of computation this morning. You have here 0.730 mole divided by 500. That is still, class. Sorry, that should not be automatically divided to 500 because remember, molarity is moles over liter. So, before tayo mag-divide, let us first convert. How do we convert this? 500 ml. What is our conversion factor? Sa isang?
Divided by 1,000.
1,000 po, ma'am.
Okay, very good. Who's that? JM, no? We have, sa isang liter, meron tayong 1,000 ml. So cancel this, you will get 0.5 liters. So let me erase this one. To get the molarity of this, we'll just divide this as 0.5 liters. So 0.730 divided by 0.5 is 1.46. Okay, very good. So you have, as you can see, you have, class, the same concentration. So eto, class, pag meron kang 1 litro, you will have 1.46 moles of the glucose dissolved. But if you have 500 ml, it will be 0.730 moles. But again, at the end, we will get the same concentration. So in the laboratory, we can actually adjust. If we want to make 500 ml of the solution, we will just adjust the amount of solute. If we want to really make 1 liter of the solution, then we will stick with the original amount of solute to be dissolved in a solution. So these are just additional things that you need to take note about the concentration. First, When you say concentration class, it is actually, excuse me, yan na pa jud nagalain ako ang tutudlan. But anyway, concentration is an intensive property. I hope you can still remember our lesson sa intensive and extensive property ha. Basig na human ang intrams kay. And this one is a prelim na lesson na to. Basig pagkahuman sa exam, past is past ang motto nato ani. So, i-review lang nato. 'Di ba ako ang gidiscuss ani pag sinabing intensive, this is independent. Independent in the amount of matter. So definitely this one is dependent. I hope you can still remember this. Independent in the amount of matter. Kagaya ng example ko class, the density of water. The density of water is 1 gram per ml. Ang isang gram ng tubig is actually equivalent to 1 ml. That is what you call density. And my illustration last time, if you have 1 glass of water, the density of 1 glass of water is 1 gram per ml. But pag meron kang isang balde ng tubig, hindi ko kabalo mag-drawing of balde. But anyway, pag meron kayo sa kabalde nga tubig, the density is 1 gram per ml. That is what you mean by independent. So it doesn't matter if you have a lot of water or a small amount of water, the density will still be the same. So the concentration is also an intensive property. As we had in our illustration just a while ago, if you have 1 liter of that glucose solution, di ba? The concentration is 1.46 m. If you have 500 ml of that glucose solution a while ago, the concentration is 1.46 molar pa rin. So it doesn't matter if you have a lot of the solution or a small amount of the solution, the concentration will still be the same. So it is an intensive property. It does not depend on how much the solution is present. Okay, that's what you mean by independent intensive property. The extensive property is the opposite. Dependent siya, kagaya ng ating volume. Siyempre, pag ang volume mo, dagdagan mo, example, meron kang 1 liter ng ganitong solution, pag dagdagan mo siya, naging 2 liters siya, so nag-iiba ang kanyang volume. So dependent siya on the amount of matter. What is this? Okay. Sige, Mariel. I'll be checking again the attendance later ha, kasi I checked the attendance kanina when we started. So, meron doong mga hindi ko na-take note. May mga nag-message dito sa chat. Let's just check later. Okay. Next, it is important to keep in mind that molarity refers only to the amount of solute originally dissolved in water, and it actually does not take into account any subsequent processes, such as dissociation or ionization of our salts or acid. So example, you have your NaCl. This is our table salt, right? So sa mga bahay nyo, pag kumuha kayo ng 1 gram of sodium chloride, dinisolve nyo siya in 1 glass of water. 1 glass of water is equivalent to 240 ml. So, pag sinabing molarity class, we will stick with the 1 gram. Okay, we will stick with the 1 gram being dissolved in our solution in a glass of water. Kasi remember, if NaCl is to be placed in water, it will undergo dissociation or ionization. What do you mean by that? It will be separated into ions. You will have the sodium ion and the chloride ion in the glass of water. So it does not really account the process, the dissociation process, but let us just stick with the original substance being dissolved, the 1 gram of sodium chloride. So that is true for our electrolytes, right? Yung mga substances natin na magkakandak ng electricity, because if you place them in water, they will be separated into ions. So just like the another example on the screen, the potassium chloride. The potassium chloride here is also a salt, and it's also an electrolyte. So if you place that in water, it will also undergo dissociation. You will have the potassium ion and the chloride ion. But in computing the molarity, we don't really account the amount of potassium being separated or the amount of chloride that is separated. Always go back with the original substance and the amount of that substance that is dissolved in our solution. Okay? Questions so far? Anyone? May pangutan na? Sig natulog na mo din ha. Kay react daw sa mga na pa diri pero mabala na to kung natulog na ning uban. Ang wala nag-react, natulog na gyud ni o kaya namahaw. Hala check. Namahaw, nagkaon naguron ni. Sana all nagkaon. Okay, sige. Nag-react man. Okay. So I hope you're still listening. So let's talk about the preparation of our solution with known molarity. So ano muna tayo ngayon ha. Dito lang muna kasi our condition will not permit us to really make this in the laboratory. So again, I will be teaching you the procedure on how to make our solutions in the laboratory with known concentration. And to be specific, it will be molarity. So what is number one? The number one step is you have to have a certain amount of solid solute to be transferred into the volumetric flask. So example, pangalanan nato kay para mas masabtan. Example, you have here 1 gram of NaCl. Kasi ito yung pinaka-common and you can just access this in your home. I believe you have your table salt there. So the first step is you have to measure a certain amount of solid solute. To be exact, you have there the 1 gram of sodium chloride or 1 gram of table salt, and we will be transferring it into a volumetric flask. Sorry. Sige, thank you. Sige, okay. Now, syempre we don't have our volumetric flask in our home. So this is how the volumetric flask look like. It's a long-necked flask and meron lang siyang isang line for graduation. Pag sinabing 1 liter class na volumetric flask, isang linya lang talaga yan siya. I believe you are familiar with the graduated cylinder, and that kind of glass for or laboratory equipment for measurement has a lot of graduation. Marami siyang linya. So meron siyang linya for 1 ml, for example, and then for 2 ml and so on. But for graduated cylinder, you have here a long neck flask but may isang graduation lang talaga siya. May isang linya. So kung para siya sa 1 litro, ang linya na yan ay mag-i-indicate na you have a 1 liter solution already. Okay? So again, if meron ka ng 1 gram of NaCl, i-transfer natin siya dito sa loob ng ating volumetric flask. And then after that, we will be adding water. Most of the time, water ang ginagamit natin to make a solution. That is our universal solvent. It is a polar substance and it can dissolve a lot of chemical substances. Now, again, let's add the water. Syempre, using a funnel because the neck of the volumetric flask is actually very small. So, if you will not use a funnel, most likely magkakaroon ng spillage in the lab. So, again, small amount of water lang ang ia-add. Okay, so in letter B, you can see that a small amount of water, and then after that, we will be having the closure here. Tatakpan natin yung ating volumetric flask and gently swirl the flask. So the reason for this is to first dissolve our solvent. We have to make sure that all the solvent will be dissolved first kasi mahirap na tayo mag-shake later or mag-swirl later if mapupunta na yung volume up to the neck. Mahirapan tayo mag-shake for dissolution. So i-swirl natin ito to dissolve the solute. So after the solid has completely dissolved, you have to add more water to bring the level to the mark. So just like this one, after na dissolve, that's the time i-complete natin ang volume ng ating solution. So how do we know na complete na? It's up to the graduation level. It's up to the mark. So if this one is a 1 liter na volumetric flask, if naabot mo na yung volume hanggang dito sa graduation, then that is now a 1 liter solution. Okay? So, what's the good thing here? Alam natin yung amount ng ating solute, which is 1 gram of NaCl, and yung ating amount of solution. By the way, let me just complete to avoid confusion. So, amount of solution here is 1 liter. That's how we prepare, class, a solution with known concentration. So, meron na tayong 1 liter. Take note of this, meniscus. I think I have already discussed this with you. If you are measuring the volume of a clear solution, you have to read that sa lower meniscus. Because if you are going to place a solution sa volumetric flask, pagkaabot niya dyan sa line, ganito yung kanyang tsura. So you have to read it here sa lower meniscus. That's 1 liter already. And that is true for clear solution, just like the sodium chloride solution. Pero kapag ka-colored solution and turbid solution class, you have to read it sa higher meniscus. Okay? So you will be reading here sa taas to get the accurate amount of the volume. So after that class, we can actually solve for the molarity na before tayo mag-move on sa ating mga examples. Pwede na nating i-compute yung molarity ng ginawa natin na solution. So again, molarity, di ba, is moles per liter. So, i-compute natin yung given natin 1 gram ni NaCl dissolved in 1 liter of solution. Okay? Can we go on directly with our computation sa molarity? What are we going to do? I believe you know what to do next. If ito yung given natin, anong una natin gagawin?
Identify po the molecular weight.
Ano sa ito, Mariam?
Yung po ma'am, molecular weight po ng NaCl.
Okay, sige. So according kay Mariam, we have to compute first for the molecular weight. So the reason for that is in the given class, we don't actually have the number of moles. Again, we don't have the number of moles here. Okay? We don't have a laboratory equipment that will directly measure the number of moles of substance, but we have analytical balances to get the mass or the weight of our substance. So to convert the mass in grams to moles, we first need the molecular weight. May chat ata. Water lang ba ginagamit sa as solution, ma'am? Actually, most of the time, it's water because that is our universal solvent. But we have solutions that actually use different na solvent. For example, ethyl alcohol can be used as the solvent to make a solution, or acetone or other pa na mga solvents class, pwede gihapon siya gamiton to make a solution. But again, most of the time, it's water. So let's, okay na to? Natubag na ko, no? Pangutana. Let's have the molecular weight. How do we compute for the molecular weight? My instruction, di ba, is to list down all the elements present in the compound. So you have Na and then you have the Cl, the sodium and the chlorine. And then the next thing to do is to determine the number of atoms. Again, number of atoms present in the compound. And how do you know that? It will be based on the presence of the subscript. So the number class na nasa baba ng symbol, that will be the subscript, and that will give you the number of atoms. But just like for NaCl, you cannot see there any subscript, that's automatically 1. So we have 1 sodium and 1 chlorine. And then after that, let us multiply this sa kanilang atomic weight. So please ready your periodic table also there para mas madali sa atin, kasi I believe hindi natin memorize ang lahat ng atomic weights ng lahat ng ating mga elements. Though I believe you know some of the most common like sodium and chlorine, pero para mas mabilis, be ready with your periodic table. So, look at your periodic table. For sodium, please use the whole number na atomic weight. For sodium, you can see there it's 23. Am I right? Kindly check. It's 23.
Yes po.
Yes po, ma'am.
Okay, very good. And then we have chloride, that is 35.
30.
35. Oh, Johanna. Very good. So this is 23 and then this is 35. And then to get the molecular weight, syempre i-add natin. Let's add 23 plus 35. This is 58. And what is again our unit for molecular weight?
Grams per mole po.
Okay, it's 58 grams per mole. So do not forget that. Ayan, so we have now the molecular weight. So we can now convert the mass into moles. So how do we get this? Our formula is moles is equal to the weight in grams. Sa taas na lang ha. So I have limited space. Divided by the molecular weight. Okay, so what is again the weight in grams? It's 1 gram of NaCl divided by the computed molecular weight is 58 grams per mole. Okay, 58 grams per mole. Let's cancel the grams. You will be left with the unit na mole. So, pwede na tayong mag-proceed after if meron na tayong mole. So 1 divided by 58. What was my instruction? Please do not round off during the process so that we will have a more accurate na result for the computation. So let's be patient with a lot of numbers here. 0.017241379 moles. Okay, so we have now the moles. Any question first before to mag-proceed? Wala? You can send your questions to chat ha, if you are unable to turn on your microphone. So let's place here now the number of moles, 0.017241379 moles. Okay? Divided by liter of solution. So, nag-imagine ta kagay na nagbuhat tano og ato ang solution. So, this is 1 liter of solution. So, syempre, let's divide this 0.017241,379 moles divided by 1 is still the same, 0.017241,379 moles per liter. Or, simply, we can write this, depende sa instruction ko. Example, my instruction is to round off the final answer to 2 decimal places. So what will be the answer now? If 2 decimal.
0.02 po.
0.02, ma'am.
Okay, Lindsay and Mariam. Very good. 0.02. You can either use the unit moles per
Mole
liter.
per liter.
Okay. And or capital letter M. That's the same. So again, either moles per liter or capital letter M, pareho lang yan. So ito na ngayon, class, ang concentration of our prepared solution. It's 0.02 molar. Ang capital letter M, how we read that as molar. Not really molarity, but molar. So ayan, meron na tayong concentration. So let me review. Pag gumawa tayo ng ating prepared solution, we have here the specific amount in grams of our solute. Let's place this in a volumetric flask, and then let's add a small amount of water, swirl it to dissolve the solute, and then add more water to complete the volume of the solution. After that, after preparing the solution, we can compute for the molarity. So our formula is molarity is equal to moles of solute divided by liters of solution. Now, since we don't currently have a laboratory equipment that will measure the number of moles, then all we need to do is just convert the weight in grams into the number of moles using the formula you can see on the screen on the upper left side. Moles is equal to weight in grams divided by the molecular weight. Okay? So, questions, class, about this? Anyone who is confused sa preparation or sa computation? Wala? Wala question? Can I clear the writings on the screen now? Pwede na? Yeah. So let us move on. Let's have the sample problem here. So let's read how many grams of potassium dichromate are required to prepare a 250 ml solution whose concentration is 2.16 molar. Again, our question here, how many grams of potassium dichromate are required to prepare a 250 ml solution whose concentration is 2.16 molar? Okay, can you please compute first in your notebook or sa inyong mga scratch paper there? And let's kindly send your answers sa chat. I'll be recording that sa inyong recitation, the first 5 only. So i-PM lang ha, i-PM sa akin yung answers ninyo. So you try first and then let's see later if we will get the same answer. So please follow what we have done a while ago. But please understand first the problem. Ang hinahanap dyan is the amount in grams na kailangan i-dissolve in a 250 ml solution if ang gusto natin na concentration is 2.16 molar. Okay, I'll be waiting for your answers sa chat. Giving you time. If you have questions, you can ask questions. While you are answering, let me drink water first. I'll be back. Meron ng dalawa na nag-send ng answers sa chat. Let's wait for other students. Hilig mo answer. Two decimal places before I forget. Hilig mo answer, kindly check there in your computation kung tama ba or there is something wrong. Ano na question mark? Pag may question mark, dili sigurado. Okay. Sige. Thank you for informing me, Fredade. Sige. Okay, tama na ito. Wala nang maghabol. You're late pala in the laboratory. Sorry. Thank you for informing me. Dili sure. Pag na-question mark, dili gina sure ba? Sige, let us try. Katawa ko, wait lang. Okay. So what are we going to do? In your mathematics na class, even in elementary, always kayong nire-require to write the given. This will actually help you in the process. You will be identifying what is already given in the problem and what is asked in the problem. Para guided tayo. So let us list down the given. So what are these things? You have here 250 ml of solution. So let's write this. So this one will be the volume, syempre. 250 ml as the volume. And then the concentration in molarity is 2.16 m. Again, 2.16 m. That's the concentration. Now, what is asked in the problem? What is asked in the problem? It's the grams. So this will be the weight in grams. Okay. So pabaliktad ito class na problem because example natin a while ago, we started with the weight in grams and then we ended with the computation of the concentration. This time the concentration is already given. The problem here, the process here supposedly is you have the grams and then you will convert it into moles and then we will be computing for the concentration in molarity. This is supposedly the process. But this time, this problem is the complete opposite. The concentration is given, that is still in molarity. So all we need to do is to look for the moles. And then after getting the moles, we will be computing the grams. So ito lang talaga yung process class para madali ang life. Hindi ta maglibog-libog sa atuang computation. So meron actually strategy dito. How many moles of potassium dichromate does a 1 liter or 1,000 ml or 2.16 m potassium dichromate solution, or a 250 ml, or how would you convert moles to grams? Pero actually, maglibog na mo if atuapan ni silang i-compute isa-isa para mas madali ha, kasi this one is written in the book. I'll just teach you the easier one sa pag-compute. So, asata, this one, we will use this process. You have there the concentration. Just go back to the formula, class, ha. The formula is molarity equals moles per liter. And as you can see in the given, you have there the molarity and the liters. So, though hindi naman talaga totally liters, but yes, we can convert ml to liters. So, kaya ang una nating hahanapin is the moles. So, either class, i-substitute mo na lang dyan yung mga given or you derive the formula. So, if you substitute, the molarity is 2.16. Please use the moles per liter. Do not use the capital letter M in the computation. Bakit? For us to clearly cancel the units. Kasi pag capital letter M, we cannot really see how are we going to cancel the units and just have the desired one. So we are looking for the moles here. And then the liters of solution, this is 250 ml. So please do not forget to convert, ha. Do not use ml in the computation of molarity. So the ml here, sa baba siya syempre to cancel. And then sa isang litro, kanina sabi ni JM, meron tayong 1,000 ml. So let us cancel this. This will be 0.25 liters. Ito yung gagamitin natin, class. 0.25 liters. So, ayan, we can compute for the number of moles na. What are we going to do? Cross multiply. Ibaba mo si moles. Wala ka namang i-multiply sa kanya. This time, we will multiply 2.16 moles per liter. Multiply natin siya sa 0.25 liters. And as you can see, you can cancel the liters, class. Ang maiiwan na unit is the moles. So let's multiply 2.16 times 0.25 is 0.54. Okay, very good. 0.54 moles. So yes, na-compute na natin yung number of moles. Ang gagawin na lang natin is to convert this into grams kasi that is asked in the problem. How many grams daw of the potassium dichromate? So you can actually use the previous na binigay ko na formula. Diba, sa previous slide, nagbigay ako ng moles is equal to weight in grams over the molecular weight. So as you can see here, na-compute na natin si moles. And then for the molecular weight, though hindi naman talaga siya given in the problem, but we can actually compute for the molecular weight. And then the weight in grams, syempre ito yung hinahanap natin. So let us substitute, but if you are more on deriving the formula, that's okay. I just want to substitute this 0.54 moles equals weight in grams divided by, yes, you have question?
Wala po yung
Nawala
audio
kanina
ninyo.
yung audio mo kanina, ma'am.
Sorry. Why? What happened? Class. Asa dapit na cut. Let's go back na lang. Again, we have computed for the number of moles. So we will be computing now the weight in grams. So the number of moles will be substituted here. You have there 0.54 moles. And then we are looking for the weight in grams. And then before class proceeding sa computation, let's get the molecular weight. I have limited space, but wait lang. Let's compute here sa taas. The molecular weight of our, what is that? Potassium dichromate. It's K2Cr2O7. So, ang first step again, list down all the elements. So, you have there the potassium, the chromium, and the oxygen. And then, pag na-list down mo na, identify nyo class how many atoms are present in the compound. So for potassium, as you can see, it has a subscript na 2, which means meron tayong 2 atoms ni potassium. And then,
Wala
Ma'am,
audio
nawala
mo,
po
ma'am.
ulit, ma'am.
why? Do I have a unstable connection? Lahat sa inyo, nawawala ako. I mean,
Naputol po siya, ma'am.
Yes po,
Yung
ma'am.
audio nyo lang po, ma'am, pero yung movement nyo po, hindi man siya putol-putol.
okay, so what is happening? Can I try to turn off my my video kung magputol-putol pa ba? Mag-turn off sa akong cam. And then let's see later if okay na ba kung audio ane. Sige, let us continue class. Chromium, meron tayong subscript na 2 here. So let's write 2. Meron tayong 2 atoms of chromium. And for oxygen, we have 7. And then, let's multiply each of them sa kanilang atomic weight. So please look at your periodic table. I don't have a periodic table here, class. I know the atomic weights of some elements, especially the common ones, but I cannot memorize everything. So please look at the periodic table. What is the atomic weight of potassium? Please round it off to the nearest whole number.
39 po.
39 po.
Okay, very good. 39. How about chromium?
52
po.
po.
52. And lastly, syempre, the oxygen is
16 po, ma'am.
16. Very good. So, ayan. We have identified, para sa mga hindi nakasunod, saan ito galing? This is from the subscript. This is the number of atoms present. And itong mga numbers dito sa column na ito are the atomic weights of each element rounded off to the nearest whole number. So all we need to do is to multiply each of them. 39 times 2 is 78. Okay, very good. And then 52 times 2 is
104.
okay, 104. And then 7 times 16 is
112 po.
112. And then after that class, i-add natin sila lahat. Let me just write it here. I-add natin sila. 78 plus 104 plus 112 is
294 po.
okay, very good. 294. Ang unit natin is grams per mole. Ayan, so na-compute na natin si molecular weight. We can proceed in the computation of the weight in grams. Let's just substitute it here. 294 grams per mole. So kapag ganito, this is the same thing with the previous one dito. Ito. So let's cross multiply. Baba natin si weight in grams. And then on the other side, let's multiply 0.54 moles times 294 grams per mole. As you can see, we can actually cancel this kasi nasa baba si mole dyan sa 294, ito nasa taas. Ang may iwan na unit, syempre in grams. So 294 times 0.54 is
158.76 po,
158.76.
ma'am.
Okay, very good. 158, this is the final answer. 158.76 grams. This is now the final answer. So, nasagot na natin na how many grams daw yung kailangan na potassium dichromate na i-dissolve in a 250 ml solution para yung concentration niya ay 2.16 molar. So ang sagot, kailangan natin ng 158.76 grams. So kapag kabaliktad yan siya class, mag-measure tayo ng 158.76 grams ng potassium dichromate, i-dissolve natin in 250 ml solution, automatic the concentration will be 2.16 molar. Questions? Anyone? Let me try. Wala na, naputol ako ang audio, no? Let me try to turn on again my camera. Kung maputol unya, may problem dito sa internet. Wala. Let me check the answers sa chat. Did we have the same answer? Saan nag-start? 158. Okay. Saan ako listahan? Lista pa kay para ano ang inyong recitation. We have, okay, Mariam.
Ay, ma'am, na ako'y pangutana. What if ang pagkasulat nila, ma'am, is na-convert nila, so naging 159 na lang?
Oh, it's okay. It's okay. But if we have our quiz or sa exam, you really have to follow the instruction ha. If sinabi ko na you have to round off your final answer to 2 decimal places, then give me the 158.76. Pero kung sabi ko, round off the final answer to the nearest whole number, then that will be 159. Okay? So do not forget that following instruction is very important sa mga quizzes or sa exam, especially sa inyong board exam. So you really have to read the instruction carefully, or if the proctor has instruction, you really have to listen and follow it again para hindi tayo magka-problema. Wait lang kay Lobat. So that is 158. Hazel also. And then, sa ko ingat na 5 na 5. So 5 persons will be credited for the recitation. Sian also. Wait lang. And then, okay, Jamwell. Yung mga nabilong sa group 2 ng laboratory, you have questions? Ilan na to? Wait lang. 1, 2, 3, 4. Last one. Let's have 158.8. Okay, Harid. Let me consider this. Yung mga nabilang sa group 2, do you have questions sa pag-compute nito? Alin dito yung hindi naintindihan? Wala yung pangutana. So let us move on. Clear na for Dave. I hope you got that. Another example. Let us check. Actually, may answer ito sa next class. Sa next na slide. But I'm not really into giving you this one, the answer. So kasi talaga pag computation, sinusulat ko step by step para masundan niyo siya. But nevertheless, this is actually the same. And we have the same answer. Though nag-round off lang into the nearest whole number. But for the sake na discuss natin, the first step is to determine the number of moles. So that's what we did a while ago. We computed for the number of moles using actually the formula. Molarity is equal to moles over liter. Ito, dinerive ito na formula. Moles is equal to molarity times liter of solution. So that's 0.5 0.54 or 0.54 or 540 moles of potassium dichromate. And then after that, we computed for the molecular weight. Other name for molecular weight class is molar mass. Parehas lang yun sila ha, molar mass or molecular weight. Although in this case, hindi sila nag-round off ng atomic weights into the nearest whole number. Ang sa akin kasi, pinapa-round off ko yung molar or atomic weights sa whole number para uniform tayo lahat. Kasi magkakaiba tayo pag gumamit tayo ang iba gumamit ng 1 decimal, yung iba gagamit ng 2 decimals. Pagdating sa final answer, mag-iiba yung final answer. So let's just round it off to the nearest whole number. After that, pag alam mo na yung molar mass, we can actually move on with the computation using the formula moles is equal to weight in grams over the molecular weight. Ito, derived din ito na formula. The weight in grams is equal to the moles times the molar mass or the molecular weight. But nevertheless, we will be having the same answer. Ito na round of ito, 159 grams of potassium dichromate. You want to have another example, no? Kasi the next slide will be about dilution. Let me just add a blank lang na slide para I'll have more space. Asa na to dapit? Sample problem. Okay. Let's have more example of this. Okay. Ayan, let me write the problem sa screen. Type ko na lang. Wait lang. Okay, I hope you can see it. So on the screen, your internet connection is unstable daw. I hope dili siya magputol. But again, what is the concentration in molarity of a 460 ml solution containing 10.5 grams of magnesium chloride? Is our problem. Okay? Sige, you try first. Kayo muna. And then later, we'll solve it sa screen. Let's see if we'll have the same answer. Dahil na mag-answer, let us kindly review your computation, what went wrong, or kung tama ba talaga. So, lahi-lahi mag-answer. We only have two processes, right? The first one starts with the number of grams, convert it to the number of moles, and then you can compute for the molarity. The next process will be a totally opposite one. You have the molarity, get the number of moles, and compute for the number of grams. So please understand the problem kung aling process ang gagamitin mo. Okay. 1 minute more. Pas. Sorry, pas kaya kasi we have limited time. Can either use capital letter M or moles per liter. It's the same thing. May na-disconnect. Ngayon may nasag na answer sa chat sa Facebook. Diri lang sa chat sa ano. Chat lang sa Zoom. Okay. Okay. Sige, let us solve this one. So what is the concentration in molarity of a 460 ml solution containing 10.5 grams magnesium chloride? Actually, ano na siya class, gituyo na ako, nawala na ako gihatag ang chemical formula. I need to check whether you still remember how to make the chemical formula. So, first step, let's list down the given. So the given in the problem, we have 460 ml. Syempre, this will be the volume of the solution. And then the weight in grams is 10.5 grams of magnesium chloride. What is the chemical formula of magnesium chloride?
MgCl2 po.
Very good, Mariam. MgCl2. So please check there kung tama ba ang inyong chemical formula. MgCl2. Ano yan siya naging MgCl2? Remember, when you write the chemical formula, first write the symbols. Magnesium is Mg, chloride is Cl. And then determine their charges. Please look at your periodic table. Magnesium belongs to group 2, so it is positive 2. And chloride is negative 1. And then you add this, positive 2 plus negative 1, syempre is positive 1. So if it is not equal to 0, you have to do the crisscross. So you have here 1 for magnesium, no need to write 1 though. But for chloride, you have the subscript na 2. So I hope tama yung chemical formula nyo dyan. So magnesium chloride. So what is asked in the problem? It's the concentration. So if these are the given, and this is asked in the problem, the concentration, the process will be, you start with the grams, you look for the number of moles, and then you have to move on with the concentration in molarity. Okay? So, Given ang number of grams, so we will be computing for the moles using this formula. Moles is equal to weight in grams divided by the molecular weight. So the weight in grams here is 10.5 grams, but the molecular weight is not given, so you have to compute first. The same process. Wait. Let me have a space for this. I'll be writing it here. So, di ba, in the computation of molecular weight, you have to list down all the elements, magnesium and the chloride. And then identify how many atoms are present. Syempre, for magnesium, you cannot see a subscript there. It's automatically 1. But for chloride, it is 2. And then multiply each of them to their respective atomic weights. What is the atomic weight of magnesium? Round it off, please.
24, ma'am.
24. So this is 24. For chloride, it is
35 po.
35. Very good. So this is 24 and 35. So i-add mo siya, class. 24 plus 35.
Ma'am, times 2 po
Ma'am,
yun.
i-multiply po.
Sorry, this is times 2. Thank you, thank you. Ayan. So this is how many? 70. So 70 plus, I cannot see. Nagaharang magudang screen sharing. Wait. Baba ko na lang siya. Ayan. So 24 plus 70. So 4, 7 plus 2, it's 94. So 94 grams per mole. So we will be dividing it here. 94 grams per mole. Balik ko siya sa taas. Kaya dili na po na ako makita ang sa baba. So 10.5 divided by 94 grams per mole is 94 grams per mole. So this is 0.111702.127. Cancel ang grams ha. So mole ang ating unit. So meron na tayong moles. Pwede na tayong mag-compute ng concentration. Molarity is equal to moles of our solute divided by liters of our solution. So moles here, again, computed natin is 0.111702.127 moles divided by the liter of solution. The given is 460 ml. So please do not forget to convert this kasi liter talaga for molarity. So sa isang litro, meron tayong 1,000 ml. Cancel this one.
0.46 po, ma'am.
Okay, very good. 0.46 liters. So, pwede na tayong mag-proceed sa ating computation. So, 0.111702.127 mole divided by 0.46 liters, you will get 0.242830712 moles per liter, or kung 2 decimal places, this is 0.24 moles per liter, or simply capital letter M. So this is the correct answer. I hope nakuha nyo ang answer na ito, 0.24. This is where we'll end. It's 8:57 already. Let me just take note of the recitation. Mariam. Okay. Abing. How do I read your name again? Miss Abing?
Santi po, ma'am.
Santi, okay. And then, Arbilo. And then, I hope dun sa mga hindi 0.24 ang answer, nakita niyo saan sa process kayo nagkamali. Ton also. And Adolf. Okay. Sige. Questions before tayo mag-end. Nabaliktad pag-divide. Mali mong answer. Okay. So, ang importante, kung maliin yung answer karon, nakita niyo sa process, alin dyan sa process ang may na-miss kayo or mali yung inyong execution. Okay? So, dito muna tayo mag-end sa molarity. Tomorrow class, we will continue with dilution and the gravimetric analysis, the acid-base titration, and the redox titration. Please study. I might or might not give a quiz tomorrow. So again, please prepare na lang daan. Wala na ba kayong questions or concerns before tayo mag-end? Para hindi kayo malate sa inyong next class? Yes, Adrian. Regarding sa nakamiss, yeah, you can still take the quiz, the special quiz, just like what we did in midterms. I'll be giving a schedule for the special quiz as long as you have a valid reason. And for me to check if your reason is valid, you need to have your proofs right. So please secure that. Huwag niyong walain kasi I'll just give you the schedule sa special quiz. Okay? Anything else? Let me stop the recording first pala.